Okay everyone, we're going to jump straight into the fourth part of this series where I think things are going to start looking like real parts now. So we're going to turn 2D sketches into 3D geometry, and you can really start to see where parts can be made in a number of different ways. And the way a 2D sketch turns into a 3D part is sketch a quick rectangle here. Just to be extremely thorough, we're going to throw some dimensions on it, make sure it's fully defined. 100 by 50, I'm okay with that. So once we have our sketch, we know what we want, we're going to go ahead and hit the finish sketch, and you have a couple options now. These are typically called your features. There's a bunch of them. Mostly what's going to be used is the extrude. It's going to be a huge part of what we use. Very seldom do I even use revolve, sweep, or loft. And it becomes less common the farther you go down the list. Hole is actually used quite a lot, so that's the exception to that rule. But when you're doing extrude, there's a lot of different choices here, and extrusions can be done in a lot of ways. There's a lot of different options within this window, so when this pops up, you can do a lot here. And this is, you can push and pull, and this is, I think, used in most CAD software packages. It's very intuitive in Fusion. They put a lot of emphasis on using that. I think they call it freeform, but in any case, you'll be able to pull it. I don't recommend doing that, but it kind of gets an idea of what it looks like and what Fusion is doing. So if I wanted it was 100 millimeters by 50 millimeters, and let's say I wanted it 25 millimeters deep. So that's telling you how far you want to extrude it in that third orthogonal direction. So now you have a rectangle there, and you can start it on the plane that you've set or that you sketched on. You can also offset it, and you could set it to a certain object so it starts that sketch on whatever object that you've pointed to. I've never done that. I've never done offset either. SolidWorks has a little more comprehensive list of how you'd want to use that. In any case, though, as you move down in this window here, you're going to get to one-sided, so that means that the extrusion is single-sided. It means it's extruding just in this case, it's the positive Z direction. You can also set this in the negative Z direction, and that's indicated by a negative 25 here. In this case, though, we'll go back to positive 25. 25 here. You can also set it as two-sided, where one side is 25, and let's say the other one is 5. So now you have 30 millimeters. There may be certain instances where that's useful. And then you also have symmetric, where it's 25 on either side, so now your part is 50 millimeters deep, and it's 25 millimeters from the midplane where you've sketched. So this is the original sketch, this will be your top plane up here, and this will be the bottom down on the other side. And then there are some extent types, and that will be more important when we have other geometry that's useful in here. So for right now, that's what we'll cover here. You can also do a draft or a taper angle is what they call it. So let's go back to single-sided, because I think it'll be a little easier to see. So now you have a 5-degree angle on all 4 sides. So on this direction and this direction, and then if you change this to a negative number, it changes which direction it's sloping in at. Mostly this is used for castings and things like that, injection molding. Not too often in most other parts, just because CNC machining likes just straight square sides for the most part, at least in 3 axis. And then you can also do cutting, and that's how Fusion likes to do it, is in the same extrusion. You can either add material or remove using an extrusion, and there are different ways in which you do that. So depending on what you're doing, we'll do a cut soon, and as we get more into it, we'll talk about intersect, and that's how, if I drew another rectangle, do I want the two parts to intersect? Do I want them to be separate entities? Do I want them to cut each other, or do I want a new body? So within a part, let's hit OK. Within a part, you have bodies. So that's going to be a body here. Now if I go ahead and sketch on this, just throw a circle right in the middle. And I want to build good habits, so we're going to go ahead and make sure it's fully defined. And then we'll go ahead and extrude this as well. We will do 5 millimeters. Now it's joining it, so that means that it is now still the same body. All of that is one body. Now if I come down here, this is your timeline, and it's a little different in every CAD package. Typically this is shown as a model tree up here. But you can go ahead and edit this by right-clicking and selecting Edit Feature. So once that pops up, you can select New Body, and now you'll have two bodies here. Typically, it's not all that useful at this level. You can delete them. You can also just go ahead and edit sketches and things like that. So not all that important. Depends on how you develop your work habits when you're modeling. Not all that critical, but could be useful for whatever workflow you're using. Now if we go ahead and hit Edit Feature, instead of adding material, we can go ahead and select Cut. Now when we cut, it's giving you an error because it's not cutting anything in this direction, it's pointing upwards. So it's saying it's just assuming it's cutting in that direction when you first open it. We don't want that, so we're going to go ahead and, so you could do through all. You'd have to change the direction. So let's do this. So you can do through all, so that means you would have, let's go ahead and do it. It means you have a cut through the entire part. If we go ahead and edit, we can show what that would be using others. So distance, let's say we wanted -5. That would give us what's called a blind hole. The first hole was a through hole because it's through all. This is a blind hole, meaning there's a bottom to it, and that is 5 millimeters deep. So you have the option to, using the extrude command, to cut or add material, and you can do that in a number of different ways. Just make sure we've covered everything that's in this window. So this is the bodies. You can control what you're cutting through. Again, you can offset it, you can select to an object. You can also do a taper angle on your cut here as well. And you can do one-sided, two-sided, or symmetric. So kind of the same thing in that regard. Now you can also do a thin extrude, which is a little different. So let's see what that looks like. So you have 5 millimeters. So what that did was it assumed that that line is 1 millimeter thick. So instead of cutting the area enclosed by the circle, it cut along the circle edge. So this distance here is 1 millimeter, just as we specified in the wall thickness here. And then the distance that it cut to in this direction is 5 millimeters, and that's what we set to with the distance. So that's called a thin extrude, and you can also do that in terms of making parts. So instead of cutting, we can do a new body, and we'll go ahead and point that up. So this might be a little easier to see. So now you have a 1 millimeter thick wall thickness here, and it's 10 millimeters tall. Now, typically the extrude command is used for square parts, so something like we've done here. You can also use it for circular for very simple features like this. As you get more complex, and we'll get into this in the next video, we're going to cover the revolve feature, and that is going to do more complex round shapes. So we're going to stop there for extrusions right now. We'll get into revolve, and then we'll get into the sweep, loft, the hole pattern, the thread, which is actually really useful. We'll cover those in a single video. And then we'll get into patterning, mirroring, and that'll likely be it in terms of features for Fusion. So thanks again, guys.